Hi everyone, my name is Savannah Russo and today I will be explaining problem 14.7 in the solutions chapter, and we will be solving a weight percent problem for both the molality and mole fractions of solute. So our problem states household bleach is a 5.0 weight percent aqueous solution of sodium hypochlorite, also known as NaOCl. What is the molality of the bleach and what is the mole fraction of NaOCl? We know that this is the case because when you take 5 divided by 100 and then multiply it by 100 again, that gets you 5.0%. So now let's solve the first part of the problem. So we're finding what the molality of the bleach is within this solution. So for molality, we need to find the moles of solute and divide that by kilograms of solvent. First, let's find the moles of solute. So we know we have 5 grams of NaOCl, and if you use the periodic table, you can find that the molecular weight of sodium hypochlorite is 74.439 grams per mole, and if you plug that into your calculator, you'll find that we have 0.0672 moles of NaOCl. Next, we need to find the kilograms of solvent. So we know we have 100 grams of total solution and 5 grams of NaOCl. In order to find the water, we need to just subtract the amount of NaOCl from the total grams of solution, and that gives us 95 grams of H2O. And then in order to find the kilograms, we just divide it by the conversion factor of 1,000 grams per 1 kilogram, and that gives us 0.095 kilograms of H2O. Now we have all the information we need in order to solve for molality, so we can go ahead and plug in our values into the equation. So we have molality equals 0.0672 moles NaOCl over 0.095 kilograms of water. Now just plug that into your calculator and you should get 0.71 molality. Now, on to the second part of the problem. So the second part of the problem, we are finding the mole fraction of NaOCl. First, let's define what the mole fraction is. The mole fraction is the amount of moles solute divided by the total moles in solution. We know we have 95 grams of water from when we were solving for molality before. And if you look at your periodic table, you'll see that water's molecular weight is 18.02 grams per mole. And you can plug that into your calculator, and you'll find that we have 5.27 moles of water. Now, we can find the total moles of solution by adding our moles of water and our moles of NaOCl. And if you plug that into your calculator, you'll find that our total amount of moles is 5.34 moles. Now we have all the information we need in order to solve for the mole fraction, so we can go ahead and plug our values in to the equation of the mole fraction. So the moles fraction for NaOCl is the amount of moles of NaOCl, which is 0.0672, over the total moles of solution, which is 5.34 moles, and that gives you a mole fraction of 1.258 times 10 to the negative 2 unitless, because the moles cancel out, as we can see here. Now, just to recap this problem, we were given a weight percent problem, and so our first step was to find out the grams or the weight of the parts of our solution. So we had a 5% aqueous solution of sodium hypochlorite, and we knew that that would then mean we have 5 grams of NaOCl in 100 grams of solution. And if we subtract the 5 grams of NaOCl from the total 100 grams, that would give us a total of 95.0 grams of water. The first part of the question was asking us to find the molality of the bleach. So we used the weights that we found above. We converted the grams of NaOCl into moles, and then the grams of water into kilograms of water, and we plugged these values into the molality equation, which is the moles of solute over the kilograms of solvent. This then gave us a molality of 0.71. Next, for part 2, we were asked to find the mole fraction. So, similarly to the first part, we converted the grams of water and of NaOCl into moles, and then we added these up to find the total moles of solution. Then we plugged these values in to our mole fraction equation, which is the moles of solute over the total moles of solution, and that gave us a total mole fraction of 1.258 times 10 to the negative 2. And again, this is a unitless measurement because the moles in the equation cancel out. Thank you.